So working on R, measuring the correlation between hours and study and score, we get 0.31, which is a weak positive. It's a weak positive correlation because according to the scale, if you get a value of correlation, be it Pearson's or be it Spearman's, if you get a correlation between 0 and positive 0.5, it's a weak positive. If you get 0.5, between 0.5 and 1 is strong positive, or 1 will be perfect positive. You can get a negative correlation between 0 and negative 0.5 is a weak negative. Between negative 0.5 and negative 1 is a strong negative, and you can get a perfect negative. So 0.31 is a weak positive. If you get 0.88, if that 0.88 is correct, then your correlation is a strong positive. Okay. Now, this is 0.31, and you can do this with your 0.88. Can be easily verified using that very same Excel. Okay. So you simply go to insert, or you can go to formulas. Let's go to formulas. Go to formulas, function, insert function. So first you go to formulas and then insert functions. So you go to formulas, you have home, you have insert, you have page layout. Go to formulas, go to insert function, and bam, you'll get a little window. And here is Pearson. Even the standard deviation you can calculate, variance, average. Pearson we're looking for. I've not seen Spearman in Excel, but Pearson is there. Okay. Now Pearson asking you which two sets of numbers from where to where. You can type it in. You can type A1, 2, A8. And you see how it lists those numbers already. The X's 9, 40, 9, 40, 15, 42, 60, because it identified these are the numbers. Or you can simply see that you're on A1, you can simply go to, right, A2, RA1, A2, and just put your finger on shift and just go toggle down A1 to A2 to 8. And I didn't even notice that before. I never did that before. Cancel. You can type equal Pearson. You can write his name, equal Pearson. Okay. Double click, and here it is, equal Pearson. So you can go to formulas, insert function, get it, or you can type equal Pearson and just highlight and then close the bracket. No, that is RA1. That's RA1 because we are measuring the correlation with X and Y. It's two sets of numbers. Okay. RA1 is from A2 to A8. RA2 is from B2 to B. Okay, so if you type in it, then you have to put a comma between the first array of numbers and the second array of numbers. And just look at right there, look, it give us our answer 0.983. So therefore now I have made a mistake somewhere in my calculation because I'm getting 0.98 in my verification. I tell Excel to put the answer right there, and I type in 0.31. So a mistake must have happened somewhere in the calculations. Okay, so it is not 0.31 in my answer. It is 0.98 according to Excel. Please verify your answer in Excel to see if it's 0.88. Okay. To go back and see where the mistake is, I will have to go back here. These are correct. These are correct. Sum of A2, sum of XY, X squared, Y squared. Okay, let's go back. Try to locate where the error is. Okay, 7 times 1551, 215 times 414. Okay, what I can also do, I can also use Excel to get those numbers for me. Okay, the sum of x, y, 7, so I can put equal 7 times C, 9, 08570. That's it. 08570. Sum of x times the sum of y. The sum of, so that's equal, the sum of x is in A9 times the sum of y is in B9. So I always say mistake is a learning opportunity. So you can actually use Excel to verify if these calculations are correct. 89010. Do we have 89010 here? 89010. Okay, so now if the third number is 7 times the sum of x squared. 7 times the sum of x squared. Where's the sum of x squared? Here it is. 7 times the sum of x squared. So it's equal to 7 times the sum of x squared is in D9. 62657. 62657. And then we're looking at the fourth number, the sum of x all squared, equal the sum of x A9 all squared, 46225. 46225. 7 times or n times the sum of y squared. So I suspect some problems in the formula itself, equals 7 times the sum of y squared. The sum of y squared is in E9. 195482. To me that number looking a little strange. 195482. 195482. Okay, there. Now the sum of y all squared, y is 414. 414 all squared equal, right? 414, which is in y9 and b9 all squared. That's 171396. 171396. Okay, now we need to find A, B, and C. You can use Excel for that. We can use Excel for A, B, and C. Okay, for A is equal to A11 minus A12, 19560, 19560. B is equal to A13 minus A14, 16432, 16432. C is equal to A15, take away A16, 24086, 24086. Okay, so what I need to do now is to multiply That's the numerator, right? That's the numerator. That's A, that's B, and that's C. Okay. So that's A, that's B, and that's C. Okay. So what I need to do now is to multiply, you know, B by C to get the denominator equal C12 times C13. 3957 for this number there. Go back to the working, compare this with what I have there in the working out. So an error is a learning opportunity. So that's how you can cross-check your answer to see if you're on the right track. 395, okay. 781152, and the square root of that number. So if I'm still not getting the error, time is going, and I will have to check it out and then send you the video where I got it. Okay. Right. So here now, what we are going to do, we are going to equal this now. I want to find the square root of this number. Equal, all right, open bracket, E12 raised to the power over half, okay, because square root is raised to the power over half. I get 19894.25. 19894.2. So that's where the error is. The error was in the square root of 395. So as I normally see, a mistake, an error is a learning opportunity, so you can trace back your answer. So you have just discovered a way to trace back your answer to see where you made a mistake. So, and you can use Excel to do that. So what I'm supposed to write there is 19894.25. 19894.25. 19894.25. 19894.25. Okay, so when we divide this, now compare what we are doing with the physical classroom. Would we have that opportunity to even use Excel to actually demonstrate that you can use Excel to actually work out Pearson's correlation? Okay, and we'll have to wait for on outside of the classroom, and so there's a lot of advantages with this approach. And let's compare it with what Excel gave, what Pearson gave. 0.93199. 0.93199. Now what Excel is doing, Excel have another inbuilt formula, and more accuracy and so forth. So slight difference due to rounding off and a different version slightly, because there are other versions to that formula. If you look it up, Pearson's formula, there are other versions to it, trust me. And the whole idea is 0.98 for answer, and you can see that's what we basically got, 0.98, because 2 decimal places suffice. Okay, strong positive. So let's edit this to strong positive, and here you have it, using Excel to do Pearson's both manually and directly.